do have a few announcements to make. I'm going to first ask Stacy Arneson, Branch Chief at the Disaster Information Management Research Center, to give us an update on a few things. Stacy.
Thanks, Siobhan. I just want to say that, of course, our thoughts are with all of those who have been affected by Hurricane Florence and Michael recently. And as typical, we have a wealth of information on these topics, both the storms, flooding, and associated risks and issues following these kinds of events, such as coping with disasters, behavioral and mental health issues. This year we worked closely with the Southeast Atlantic Regional Medical Library to compile information and to send it out in multiple venues to reach as many audiences as possible. The Southeast Atlantic region also worked with local partners to check on the status and the needs of libraries in the region. As an alum, I just want to say that I'm very excited about Lisa Federer's talk, as an alum is getting much more involved in open data and data science. I think it'll be exciting to hear what Lisa has to say to all of us. And I also think it'll be a nice add-on to our last presentation from our Associate Fellow, Nicole Strayhorn, who talked a little bit about open data in public health emergencies, focusing on Zika, for those of you who had seen that. And if not, it is archived on our website so that you can watch that as well. So thank you very much, Siobhan and Lisa, and I'll turn it back over to Jen or to Siobhan.
If we have Jen can give us an update on WISER.
Hi everyone. I just wanted to update you a little bit on WISER's new release. We actually have released WISER version 5.2, which has the chemical intelligence tool, the Chem Intelligence Tool version 2.0, which adds 3 new toxidromes to it. So we have irritant gas, opioid syndrome, and convulsant syndrome in there as well. And we also have added some globally harmonized system, or GHS, classifications to that, including some of the icons. So look out for the new version there. And I will put a link in the chat to that.
I did that for you while you were talking.
Oh, thank you.
Okay, and I forgot to introduce myself. I'm Siobhan Chan Blackwell. So, but I'm going to now, Jen, if you can give Lisa control, and we're going to turn this over to Lisa Federer, and we're all really excited to hear what Lisa has to say. So go ahead, Lisa.
Thanks so much. Let me just share my screen here. Okay. Hopefully you can see my slides at this point. So I just wanted to start off by thanking Dimmer for having me to present in this session today. My name is Lisa Federer. I'm the Data Science and Open Science Librarian at the National Library of Medicine. And this is a new position for me. I've just started here about a month ago. And I'm really excited to be able to share some of my experience working with data and data science with all of you. So let's get started. So as an overview for today's session, I want to talk a little bit about the sort of background of this. Why are data management and sharing something that should be considered in the context of disaster and public health and epidemic kind of information? And then once we cover that, I'd like to talk a little bit about considerations for thinking about disaster data, looking at some case studies of what has and has not worked well, and give you some practical advice for thinking about how to prepare moving forward. And then there will be time for questions at the end. You can feel free to type those in the chat box throughout the session, and I'll be answering them for you at the end. So to dive right in, a little bit of background. So I come from the research world, really. I have been working for the last about 7 years with researchers on their data management and data sharing. So there's a few things that apply here that I think have sort of driven data sharing in this context. One is that there are a number of funders that now have policies requiring data sharing. The National Science Foundation has had a policy that requires all grant proposals to include a data management plan since 2012. The NIH has recently instituted several data management plans, and as a matter of fact, right now there is out for public comment a request for information on a new data management and sharing policy that would apply for all NIH-funded grants, contracts, and NIH intramural research. So there's a lot of interest in making sure that the data that's collected as part of scientific research is made available for people for a number of reasons. This is just sort of good, transparent science. There's a lot of use in being able to reuse and reanalyze data for new purposes, and so this is something that funders are interested in. A number of journals have also started to have policies that require that if you're going to publish in their journal, your data have to be made publicly available. So as a result, in again, the research world, there's been a very big shift towards people making their data publicly available in repositories and through other means rather than just keeping it private to their lab. So this, I think, is kind of going to start being extended to more of the disaster and public health kind of world, particularly as we see some of these new epidemics breaking out. There, of course, was Zika and Ebola, and out of those outbreaks, there has been this joint statement on data sharing that you can see at the link below. And there are 57 signatories to this statement on data sharing, including, oh, I see that someone's having some difficulty with hearing me. Is everyone able to hear me okay? Okay, I'm just gonna.
I can hear you. So
Okay, so maybe it's just a.
I can hear you, but you're softer than Siobhan, so maybe you could speak up just a little bit.
Okay, I will try. Thank you. So 57 signatories to this joint statement on data sharing that include journals as well as funders. And some of these are ones that, if you're here in the United States, you're probably familiar with, the CDC, the NIH, and several of the large journal publishers as well. So the journals that are signatories to this agreement have agreed that they will make all content concerning the so let me see if I can adjust my volume at all. I see that there's several people having some issues here. Let's see. One moment. Okay, is that better? Hopefully. Turned my mic volume up, so hopefully people are able to hear me a little bit better now. Okay, yay. All right. Sorry about that. So, joint statement on data sharing. So as I was saying, the journals that have signed on to this have agreed to make all content concerning, specifically in this case, the Zika virus, free to access, so open access from the start, no embargo period. They have also agreed that any data or preprints that are deposited for unrestricted dissemination ahead of the submission will not preclude anyone from publishing in any of these journals. So if I publish anything ahead of a journal, I can still go ahead and submit that article for publication in journals. As we'll talk about a little later in the session, rapid publication and dissemination of this information is often very important. The funders that have signed on to this have agreed that they'll require researchers who are doing work relevant to any sort of public health emergency to put in place a mechanism to share the interim data, what they're collecting as they go, as long as it is of a certain quality, as well as the final data. And they are agreeing to do this as rapidly and widely as possible, and working with relevant public health funders, research communities, as well as the World Health Organization. So it's a pretty important, I think, commitment that these funders and journals are making to ensure that the data that's collected on these public health emergencies is getting out so that we can advance the science on these very serious issues as quickly as possible. So what type of data are we talking about? The joint statement that I just mentioned is very specific to a particular kind of data, but I want to cast that net a little bit more broadly in today's session to talk not just about some of the data related to these outbreaks and epidemics, but also to other types of disasters that that you might be working with. So I'm thinking here about data collected during a disaster or epidemic, as well as previously collected data that will be needed during a disaster. So, for example, if we have a flood situation going on, we will probably need to have information about, where that flooding is likely to occur based on, the geography of that area. So these are both things to be keeping in mind as we're thinking about all of this. These data are useful for a number of purposes. One is for detection and tracking. Where is this disaster or incident occurring? How serious is it? Hopefully some early detection of things that we can put a stop to something before it becomes too serious. Coordination and response are also going to be affected by having some of this data available, so figuring out where interventions need to be deployed, who is working on things, coordinating with various organizations when that is relevant. Also really important is assessing the effectiveness of interventions, partly for during a, specific disaster, but also, again, for having information for the next time, for, improving when such a thing occurs again. So is there, a vaccine that's working? Is there a quarantine procedure or whatever it might be that we can collect data on to assess the effectiveness of that? And then again, sort of thinking ahead to after the data that we've collected during an incident can be used for improving early prediction and forecasting of potential future events. I thought this was really interesting. The image on the left, I'm sure we've all seen the images of the cone of uncertainty for where a hurricane will hit. And it's really pretty striking to see how much more, sort of certain that forecasting has become based on improvement in technology and forecasting in the years since Hurricane Katrina in 2005. So that's sort of the, what we're thinking about and why we're thinking about it. And I want to sort of frame this conversation around these 4 points around disaster data. And these are adapted from an article that I think is really useful for thinking about collecting data in these sorts of disasters and public health and outbreak kinds of situations, which you can see a citation for at the bottom of the screen. This one was sort of findings and reflections based on their experience with working with the Ebola outbreak. So the 4 sort of things that we're going to think about here are, first of all, collecting the data that we need. How are we going to make sure that we're collecting all of the relevant data in the right form? We're going to talk about how to optimize data quality to make sure that not only are we collecting the data that we need, but that it's in a form that the relevant stakeholders will be able to use it. We'll talk a little bit about ensuring adequate data availability. So how do we make sure that, again, that data is able to get disseminated to the people who need it? And then finally, looking at reporting the results of various analyses. This would probably be something that comes a little later down the line, but these are also, things that we should be considering as we prepare for this type of data management and sharing of this kind of data. So I want to start first with collecting the relevant data. So the article that I just mentioned specifically deals with outbreak kinds of data, and they identify 3 different levels of data that should be collected. Again, this is specific to outbreaks, but I think you could kind of see how this would also make sense in the context of other disasters as well. So one would be the individual level, so individual cases of illness, or in the case of other types of disasters, individual homes that may be affected or families that may be affected. So looking very specifically at this individual level. Relevant in the case of outbreak kinds of disasters, the exposure level data is important as well. So looking at transmission between individuals, looking potentially at transmission from food sources or environmental sources, so that we're able to figure out how transmission occurs and of course then how to stop or curtail it. And then population level data as well. So how is the population as a whole affected? And I also really like, they refer to this as metadata as well. So there are some things that are sort of, again, that existing information that we bring into the context of a disaster that, again, you can kind of think of as metadata. So the things like, how are people in this population distributed? Where are there large groups of people, or where are there roads that would be useful to be able to transport supplies? Where are there, again, those things that, the land is lower, so they'll be likely to flood. So that information that's already there and collected that we will need to know to inform response. So, again, I say that I come from the world of research, and I think that, there's obviously a lot of different kinds of research data, but I think there's even more kinds of data when we're talking about the sort of disaster-related information, and it's not necessarily the data that you might think. A lot of this information can come from sort of non-traditional sources. There have been a number of articles that have looked at how Twitter can be used to, track information and, track sort of response to various disasters. At the end of the slides, I have a link to some sort of recommended resources, and there's an article there by one of my former colleagues from the NIH library, or at least she's a co-author on it, Alicia Levinsky, that is a really interesting use of Twitter for looking at disaster information. And you can see from this that, not everything is going to be useful. The third highest amount of tweets in relation to Hurricane Sandy was jokes, so probably not terribly useful. But again, this data can actually be a really useful real-time source of data for disasters. Crowdsourcing can also be a interesting and sort of different way to collect some data. Most of us, or many of us these days, have these smartphones that are actually very sophisticated data collection devices in many cases, and where that access is available, that can be an important source of information for collecting data and responding. So I want to talk next about how to collect quality data. We can get a lot of data, collect a lot of information, but how are we going to make sure that it's useful for the people who would be able to analyze it and get something out of it? So one important consideration, I think, is how will data be digitized? I think especially in the case of when we're looking at, disasters or outbreaks, often there might not be power. People might be collecting information and data in an analog form, writing it down, however they're collecting it. But consideration needs to be taken in advance to how that data will be digitized so that it can get distributed both in the moment to first responders and others who might need it, but also long-term, if we're going to be able to use this data to, get something out of this information, to be able to do research, to be able to draw conclusions, that data will need to be in some sort of digital form. So again, important to think about how that data will be digitized and turned into a form that can be used beyond just in the moment, here's how we are going to respond. So as we're thinking about digitization, one of the things that's really important is picking the right formats. There are obviously lots of different types of files and types of data that we can save. I've highlighted a few very popular and good for data analysis formats here. So plain text files, really useful. CSV files, which are comma-separated value files, are an excellent way to store any sort of tabular data that you might have like in a spreadsheet. XML, JSON, these are all sort of organized data formats that are useful, and they're open formats, so we don't necessarily have to use a particular program to open these files. Some of this data that we're talking about in this context might be geographic data or geospatial data. I am not a GIS expert, but there's a lot of information available about collecting this type of data, and there are some very standard file formats that are used. Shape files, for example, are sort of how the existing information about the geography is conveyed, and then you can overlay layers on top of that. So these are things that might be useful. I do want to point out that PDFs and stuff like Word docs, not data. So I work with a lot of data scientists, and I was having a conversation with one of them the other day about data.gov, and they were like, it's a great resource and it's very cool, but a lot of the data is in a PDF, and that is not data. That's not something I can use. So think ahead about what formats will be useful for saving that data and for sharing it and making sure that people can do meaningful analysis with it. So I spoke a little bit about data scientists and how they work with data. Obviously, not everyone who works with the type of data that might be collected or used during a disaster would be a data scientist, but I think that it's useful to think about sort of the best practices for data science, because these are applicable across the board, and if you have this data in a format that data scientists can use, they will likely be interested in analyzing your problem. So I like to point to this as a really good example of a community that has developed a really useful data resource in a format that a data scientist would be able to use. There are several different programming languages that data scientists will often use. One of them that's very popular is R. And this malaria atlas is an R package, so basically it's like an app or sort of an add-on for R that can be used to allow a user to download, visualize, and manipulate this data about malaria. So it's super easy then for a data scientist or anyone who wishes to analyze this data to not only find the data, but to get it in a format that works for them, and to be able to just very quickly and without a whole lot of trouble be able to analyze it. So again, I think this is a really interesting example, and I think it would be really useful for other communities collecting data that they would hope to have some analysis put to think about how to get that data out to the community in a form that can be used. So I also wanted to mention data harmonization. And this is basically the process of taking data from multiple different sources and getting them all into sort of a way that they can talk to each other. This can involve formats. We already talked about, you know, the fact that there are different file formats that don't always talk to each other very easily. And this could also involve variables, measures, and inputs. So particularly when we're talking about something that's happening say in an international context or on a large geographic scale, you might have multiple different people from different groups pulling together data, and they're not necessarily going to be doing it in the same way. So for example, I might be recording, you know, the height of something in feet, whereas somebody else might be recording it in meters. I might be using a CSV file, whereas somebody else is using an Excel file. So thinking about how all of that data can be pulled together from multiple different sources is really useful to ensure that you don't just have these little silos of data, that you can really pull everything together and again have those more meaningful analyses based on a more rich and robust data set. So this obviously is something that you would probably need to think about in advance to make some plans for. There are a number of different ways to approach data harmonization. One that I will draw attention to is common data elements, or CDEs, just because the CDE repository is hosted here at NLM. So common data elements are basically these forms that are created in different sort of disciplines or areas, or to measure specific things, that are sort of a set way of collecting and recording information. So, you know, here is an example of one very simple common data element form. So you can see that, you know, very specifically we have that the date of birth is going to be recorded in month, day, and year. You could think that, you know, if we were working with an international collaborator, a lot of them might be recording things in a different form. Like in Europe, they put, I think, the day first and then the month. Other places might list the year first. So here we have a very well-defined way that we're going to record this information. The age, that would be, you can kind of see it's a scroll thing, so we would have a set number of items that we can choose from. Same thing with these radio buttons for gender and a Hispanic Latino background. So you can see that this sort of constrains the way that we collect data and ensures that everyone, regardless of how big of a group of people we're using to collect data, no matter where they are, everyone's going to be collecting things sort of on the same page, and that ensures that we'll have a good high-quality data set that we can use and analyze without too much cleaning or having to think about how we can get those things to work together. So I want to move now to how we ensure data availability. And again, this partly refers to both how we are collecting data in the, at the time of a disaster, but also ensuring that when a disaster occurs, we will have access to the data that we need in order to respond to it. So part of this has to do with, sort of best practices for data preservation. Part of that is data redundancy. There's an acronym, LOCKS, lots of copies, keep stuff safe. So you can imagine that, if we have a very important data set and we have it stored, maybe I have it saved on my computer and I'm here in this building, obviously that is not going to be very helpful in terms of ensuring preservation of that data. If my computer crashes, that data is lost. If I lose my computer, that data is gone. Lots of things could happen if we only have one copy of a file. So it stands to reason that, okay, let's make a backup copy. Maybe I have an external hard drive that sits here on my desk. At home on my laptop computer, I have my files saved, and I have an external hard drive. That's great. I'm backing up. But those are all in my building. What if my building catches on fire, or there's a flood, or whatever might happen? I could have a million copies of my data, but if they're all in the same location, it's going to be lost anyway. So having not only multiple copies of data, but multiple area or locations to physically store that data ensures that we will have access to the data regardless of what happens, in a given location. And fortunately, now we have the option to have reasonably cheap and reliable cloud storage. So it's very possible to, store your data somewhere locally and also have it living in the cloud where it is going to be backed up. And, of course, there are instances where cloud storage has failed, but it's typically a pretty safe way to ensure a backup of your data. There's also this rule of 3 for preservation. So the idea is that you want to have at least 3 copies of a file. And those should be on at least 2 different types of media. These are, I've borrowed this image from a previous presentation that I did many years ago, and it's already outdated. You would probably not be storing data on a CD, but so maybe a hard drive backup plus the one that's on your computer, cloud storage plus one that's on a a flash drive or whatever it might be. So choosing the 2 different media that are most useful to you in your particular setting. And then at least one of those copies should be kept off-site. So again, cloud storage can be a really effective way of handling this, especially since it also has the advantage of allowing people from multiple different locations to access data at any given time. One way of handling data preservation and access that has a number of advantages is storing that data in some sort of repository. So a repository will be useful because, for one thing, the preservation is sort of taken care of for you. When you give your data over to those repositories, they are going to take on the responsibility of preserving the data and storing it. And this also has the benefit of making the data, in most cases, publicly available to other, researchers or first responders or other, whoever it is that might need this data. I'll mention at the end a couple of sort of disaster-specific repositories, but a couple of resources that are useful for finding a relevant repository. The first one, RE3Data, stands for the Registry of Research Data Repositories, and that is basically like a catalog of subject-specific data repositories. So you can put in, the type of data that you're interested in, or the, subject matter, or whatever it might be, and this will help you locate a repository that houses that kind of data. The National Library of Medicine also hosts a list of NIH data sharing repositories. These are repositories that are, in most cases, administered by one of the 27 institutes of the National Institutes of Health, or else they're in some way endorsed by one of those institutes. So most of those are fairly subject-specific around the types of research that those different institutes are funding, but that can be a useful place to locate repositories that could be relevant as well. So this is, something that I think is useful to think about in advance. Where might we put data in the case of an emergency, or where would we find data that we might need in the case of an emergency? And again, something that's useful to think about in advance. I think a lot of researchers that I work with don't necessarily think about this when they're collecting data, and so then when it comes time to share it, they really don't know where to put it. And I can imagine that that would be even more challenging in the context of something like, a disaster where time is really of the essence and you don't have time to be, Googling around trying to find a repository. Another thing to consider is licensing. If we're going to try to get data out there to be analyzed and to share it with the community and make sure that everyone who needs it has access to it, we also need to think about how we're going to license that data. So there are a number of licenses that allow you to very specifically indicate that you are making this data available for others to use in various different ways. So I've given links to several of them here. Creative Commons is one that is very popular and that you may have heard of, but there's also these other ones that are specific to data. Some of these are basically licenses that allow you to place your data entirely in the public domain. Others of them allow you to have some restrictions. So some of those common features of restrictions that you might wish to put on your license. One is that it can be reused, but only with attribution. So if someone plans to reuse or modify or remix this or publish on it or whatever, they can do so, but they have to give credit to the original author or creator. Another sort of way that you can sort of limit the licensing is with the share alike clause that most of these licenses have. So this allows people to modify if they like to share the data or the object that's in question, but any derivatives have to have the same license as the original. So if I take your data and I say combine it with another data set, I can't sell it for profit. I have to share it using the same license that the data set originally had to start with. And then you can also specify that the data or object can only be used for non-commercial purposes. So I can't take the data and develop a commercial product that I sell and make money off of. So again, these different licenses, depending on the type of data or what you would want people to be able to do with it, may have these different features that would be relevant to you. But even if you're really wanting to make data completely open, it's useful to explicitly label it as such. Because if you don't, then there's really no way for people to know that they can use it or how they can use it. So at the very least, use one of those public domain sorts of licenses so that people know that this data is open and available. All right, so next I want to talk about analyzing and reporting the results. So we've got data, we've got it collected. How do we get that information out? So I've mentioned several times that I come from this research world, and so I'm very familiar with the journal publication process, and that typically would not be super useful in the case of disasters. I think the joint signatory thing that I mentioned earlier, the joint agreement about open access to data and articles, is a good example of this. If we had written a paper on Ebola or Zika and submitted it to a journal, it can take months, if not years, for that to actually appear in print, and by then it's really too late. So, important to think about how to get this information out quickly. So I've mentioned repositories. Those can be repositories for data, as well as things like the Open Science Framework, which I thought I had a link to this on the slide, but I apologize. I haven't included the link here. The Open Science Framework is basically a forum for sharing not just data, but also things like code used to analyze the data, images, articles that go with it. So you can get a lot of information out very easily, and it's all open for people to use. Another way that can be useful to disseminate information is through preprint servers. Archive is just one. There are several that are more subject specific, but these allow for quick posting of articles, and what's also kind of nice, comment on those articles, so the community can interact with that and the authors can see that. So if I have some really important information that I want to get out quickly, I can put that on a preprint server. One of the other things that's kind of nice, as that joint declaration stated, preprints don't necessarily count as prior publication. So if I'm someone who's collecting data and I want to get the information out quickly, but I'm also a researcher and I want to be able to get academic credit for publishing my article in a really important journal like Nature, that doesn't necessarily preclude me from doing so. So preprint servers are a useful way of getting information out on a very rapid basis. It's also important to consider, though, that rapid reporting should not we should not substitute, high quality reporting for this. So you want to get information out, but you want to make sure that it is correct, that it is undergone quality control, that it's in, those proper formats, that it's harmonized. So rapid, yes, but correct as well. So another piece to think about is responsible reporting. So some types of data that would be collected in instances like this could fall under the common rule or other regulations that apply to human research subjects. So, we have to think about, if we are collecting data on patients or on humans, how do we report that responsibly and still ensure that their privacy is maintained, and that, we don't put out personal health information or other sensitive information about individuals. It's also important to think about sort of ethically, what should we report about certain things. This is a link to an article that was pretty controversial when it came out. This was a study that looked at mutating the avian flu virus to be able to be transmissible between mammals. And there was a lot of controversy, again, when this was first before it was published, when it was accepted for publication, because it sort of made it possible then, now we would know how to potentially mutate this, to make this transmissible between humans, and are there ways that, for example, terrorists could use that information to be able to create some sort of, bioweapon. And so we need to think about how to convey information in a way that will get the information to the people who need it, but also, again, maintain privacy and, ensure that people who don't need access to that information don't get it. Another issue to consider is giving credit where credit is due. So, we are talking about things where, you're probably collecting a lot of information in the moment, and you're not necessarily thinking about oh, I want to make sure that I can put this on my CV for tenure. But that kind of thing is actually important in some cases. Here again is, and I apologize, I forgot to put the link on this one too. Link to an article about another controversy around using shared data, in this case again, the flu virus. So there's a flu repository called GISAID, and people can put information about flu genome in there. And so this Chinese group put that information in, someone else published on it, and did it credit them in the way that they wanted to be credited, and so that became a bit of a controversy. So again, when we're talking about anything that sort of involves especially scholarly publication, it's important to make sure that if we're going to reuse data, we're doing so with respect to the creator or author who collected it. So I've included links here to a couple of resources for data citation. One is DataCite. This is an international organization that facilitates access to data by assigning digital object identifiers to data, or DOIs. So having a DOI allows for one thing, for persistence. So we know that whenever we want to access this data, we can go to the DOI and we'll be able to find it, even if it's moved, where it's stored on the internet. It's also a unique identifier, so we can be able to point specifically to a certain data set, or even a certain subset of a data set, depending on how, with what granularity they have assigned those DOIs. And most importantly in this case, it allows us to be able to cite that data set, so that for one thing, we're giving credit to the group or person who collected that data, but also it allows other people who maybe are reading my article to be able to easily go back and find that data set as well. The second link here is to Force 11's data citation principles. This is a list of 8 principles for data citation. They're sort of more high level than the data cite piece, but it's useful for thinking about in terms of how do we want to be able to give credit to people? How do we want to be able to track data? So that's something I think interesting to be thinking about as well. So I've covered a lot of sort of high-level things here, but I wanted to, sort of move on to a little bit more practical piece now, and that is, what can we be doing now to prepare? As I said before, and as I'm sure all of you know, pre-planning and preparation is super important because, at the time a disaster occurs, it's really too late to be thinking about some of these things. So one of the things that I think is important is really just thinking about what kind of data will we need to collect, how are we going to collect it, how are we going to store it, how are we going to share it. So some of these practical pieces to think about, most people that are collecting the type of research or type of data that we're talking about here wouldn't have to write a data management plan, but I think that these data management planning types of things are actually really useful for just providing kind of a framework for thinking about things. So these data management plans are, as I mentioned earlier in the session, required by some funders. So if you are going to require, if you're going to apply for a grant, you have to submit a data management plan. Again, this probably, there won't be such a requirement for the types of data that would be, within the purview of what we're talking about here. But again, it's sort of a nice structured way to think about what would we need to be aware of. So things that you might not necessarily think of are sort of outlined here. So I've listed 2. The DMP tool is one that is out of the California Digital Library along with some of their partners, and it has a number of U.S. funders, so templates and sort of interactive way to build a DMP that would meet the requirements of various U.S. funders. But again, just sort of, even if you don't have to submit one to a funder, just a useful way to sort of get some ideas to think through. And then this other one, the DCC checklist for a data management plan, is from the Digital Curation Center in the UK. This one is a really, really long checklist, so it might look a little bit overwhelming. There are I think several hundred items on there. Not all of them obviously will apply, but again, just sort of a useful framework for thinking about, what considerations might we need to, be keeping in mind as we do this. So, if this is sort of the first time that you've thought about data management and sharing, or if you're working with groups who have not been used to thinking about this before, these can be really helpful ways to ensure that you're really sort of checking all the bases and preparing everything that you might need. Another really important piece is developing that infrastructure for getting data out, for sharing it. Again, by the time things are going on, it's too late to think about. We want to make sure that everyone knows in advance where we're going to put data and where we can find that data. So here again, I mentioned earlier that these are sort of specific to disaster kinds of data. The Humanitarian Data Exchange has, as you can see here, a very large number of data sets. Not all of them are necessarily related to like disaster information. There are other sorts of, humanitarian crises that they have data on, but there's a lot of really interesting and useful data here. One of the other things about this is that pretty much anyone can access the data, but you have to be an approved organization to be able to upload the data. So you can, sort of trust that the data here is going to be authoritative and correct, and it comes from a vetted source. So, if you're working with the type of data that would fit in here, for example, I know that they host some Ebola and Zika data. It would be worth perhaps thinking about becoming one of those approved organizations so that, if the event happens that you do have data that you've collected and want to share, this is a way you can quickly and easily do so. And again, share that to the community so that they know where to find it. FEMA has a number of different data resources which you can find on their website, and this one in particular I thought was interesting. It's GIS data, so geospatial data about specific emergency management and disaster situations, so that can be useful if you're looking for or wanting to share that kind of data as well. So I mentioned this, training and outreach. How do we ensure that everyone knows the plan? I had to include this dog on the slide. I don't think he's training for data collection during disaster, but he is very cool and he's training for disaster response. So again, sort of communicating to the community, both the people who would be collecting data as well as the people who would need to use that data so that we all know in advance what the plan is. Just the same as we do fire drills, so we know when we leave the building where we should go and find everyone, so we ensure that no one has been left behind. It should be included in the sort of pre-planning and training to prepare for these sorts of things, that we consider again, how we're going to collect data, where we're going to put it, what the plan is. So as I said, I've included some additional reading here just to sort of quickly walk you through this. The first one is a really interesting background briefing for the World Health Organization on preparation for thinking about data and results sharing during public health emergencies. It's brief, but it does a really good job of introducing some of the challenges and barriers as well as ways of overcoming those challenges and barriers. The next one is sort of a more general piece that looks at how can we make this data sharing sort of part of the way that we just think about responding to public health emergencies. The third one is that article that I mentioned earlier that I think is a really, really useful article, not only for thinking about outbreak data collection, but just sort of generally disaster information. The second to last one is that example that I mentioned of using Twitter as a way of collecting information for sort of surveillance during a disaster. And then the bottom one is an article that has to do with that sort of responsible reporting piece that I mentioned. How do we make sure that we share data, but we do so in a way that is going to be responsible and ensure that it sort of doesn't fall into the wrong hands. So that wraps up everything I had for you. My contact info is here. I am on Twitter. I tweet a lot about data and also my dog. So you can reach me there, and I'm happy to take any questions that you have at this point.
Wow, thank you, Lisa. That was just so, that was just amazing. You covered so much material, and we really appreciate it.
Thank you.
Just so the people on the call know, we do post your PowerPoint and the recording of this webinar to our website. We will also pull out all of these links and create a handout so that people can have a handout of all of the resources that you shared, not having to go into the PowerPoint to get them. I know Jen's been monitoring questions as well as filling in so much information in the chat box. Jen, do you have questions that people put into the chat box for Lisa? Jen, maybe you're muted if you're talking.
Sorry, yes, I was. Thanks. We have a question from Allison about what about backup systems like Box or the cloud?
Yeah, that's an excellent point. So having data stored on some sort of cloud storage system is an excellent way to ensure that even if something befalls your physical data on your computer or whatever, you will still have that data backed up. In some cases, if you're collecting any sort of human data or human subjects data, anything that might be private, not all of those are HIPAA compliant. So if that does apply to you, you would need to think about sort of vetting the source that you use. But I know that Box.com does have, I'm not sure if it's like by default, but I know that it is possible to have the sort of level of security for that ensures that it's HIPAA compliant. And as like I said, the nice thing about that is that if you have data on the cloud, people can access it from pretty much anywhere. Just in my personal case, I am currently working on my doctoral dissertation, and I sometimes work in my office, and I sometimes work on my laptop at home, and it's kind of annoying to have to email myself those files, but I save it, in the cloud, and that way, wherever I am, I can access the most current version. So, yeah, those are great solutions for a number of different reasons. Yeah.
Great, thanks. I don't have any other questions just now. If anyone else would like to ask Lisa a question, please go ahead and type it into the chat box right now. Siobhan, do you have anything else?
Well, I just know that that we're all trying to figure out what role libraries play in this helping researchers and scientists with the organization of data and around the topic of disasters and public health emergencies. So this gives us a lot to think about.
Yeah, and I think librarians and other information professionals really can have an important role in this. This is something that, sort of the library community, or at least the academic library and health science library community has really started to think about this, sort of data piece. And so, I think that in many cases, probably, the communities that you might be working with haven't really thought about this, and I don't imagine that that's been communicated to them in the same way that it has to researchers. And so I think, this is a great opportunity for librarians and others to sort of bring these best practices in for groups who might not be thinking about it.
Okay. Well, I don't see any more questions, and we're getting close to the end of the hour. So thanks so much, everyone. Again, you have Lisa's contact information. Lisa, can you hand the ball back to me? I do want to talk about how to, here we go. Oh, I thought it was, oh, I know what it is. It's the next slide. There we go. If you, whoops. If you want to get MLA-CE credit for this class, you need to take the survey, and I think Jen's going to put the information about this, the links into the chat box. So you can fill out the survey and then log on to the Medical Library Association website, their learning management system, and enter the code DIS data, and then you'll get your MLA-CE. We'll be adding the recording, the slides, and a handout onto our webinars page. And we have an idea for our November meeting, although we have to contact all of the speakers. So we hope to be back again in November with a call and then take a break for the end of the year. So thanks to everybody for joining us. Thank you so much, Lisa, for your content and your wisdom. And we'll see you all again in a month.
Hang on just one second, Siobhan. We have one more question.
Oh,
so Lisa, yeah, you can't see because it was sent privately. So there's a gentleman here who says, if I have files on my computer, on a secure flash drive, and on the county server, does that satisfy the rule of 3? Does the county server count as a third storage location?
Yes, so I would say likely, assuming that county storage is not like physically located in the same place that your office is, yeah, that would satisfy the rule of 3 for sure.
Great, thanks.
Okay, now we'll say so long, and we'll see you all again in a month. Thank you.